In the previous lecture, we have seen what is LPDT, Language Processor Development Tools. So the first tool in LPDT is LEX, which is Lexical Analyzer Generator. I, Professor D.V. Kosti, welcome you in this lecture. So let us start with LEX. LEX, Lexical Analysis Generator, which accepts the input specification, which is of two different types. First component is the specification of string representing the lexical units in the language L. That is, if we say the string is representing IDs, then specification for generating lexical units of IDs must be given. If we are writing the specification for constants, then the string representing lexical units of language L must identify constants. So for that, specification must be given. So this specification is in the form of a regular expression. Now you know what is meant by regular expression. Now this particular regular expression will be able to identify a particular ID or constant depending on the need of the example. It can be in combination also, so no problem. The second component is the specification of semantic actions aimed at building an IR. Means after matching a particular string, that may be ID, that may be constant, then the action must be taken depending on the identification. So these actions are given in the semantic actions. Let us see the structure of LEX program. The first component is enclosed. The first component is enclosed by the sign given here, percent opening curly bracket, closing curly bracket, and percent sign. So this is called a specification. It defines the symbols used in the specifying the string of language L. So this is the first component. The second component is called as translation rules. So this is given in between double percent and double percent signs. So the second component is also an important to give the translation rules. Third component contains the auxiliary routines. See, auxiliary routines means the semantic actions which can be performed depending on the identification of a particular string. Without wasting much more time, let us see the example. So in this example, you can see the specification part. Later is accepted if there is a combination of capital A to capital Z, small a to small z. Second part, you can see the translation rules. If the string is begin, then what is to be done? If the string is end, then what is to be done? If the string is equal to, then what is to be done? If the string is satisfying later into another bracket later or digit star, then what is to be done? If the string is satisfying digit plus, then what? So these are the some translation rules which is doing some task. Now, in the specification you can see letter can contain A to Z, capital A to Z, any combination, and small a to z, any combination. Digit can accept any combination between 0 to 9. So what is meant by letter and what is meant by digit is clear in the specification. Now in translation rules you can see if there is a combination of letters as B, E, G, I, N, then return begin. That means at the start. If there is a combination of letters E and D, return end. Next is if there is a equal to sign, then return ASGOP. ASGOP stands for assignment statement, assignment operator. So ASG stands for assignment, OP stands for operator. So this is called as assignment operator. So next is later into another bracket later or digit star. So this you know, star means 0 or more occurrences. So any ID is starting with letter and it can continue with letter or digit or continuous letters or continuous digits or letter digit combination, anything, or there will not be any occurrence of letter or digit. So example of this can be int a is also a is id. So in this case only letter is there. If we say int a1, then letter is taken and one digit is taken. That is also okay. If we say int a1, then one letter, another letter, and one more digit, AA1. So this is also possible. So I will not waste much more time on ID. You know the rules to define ID. ID cannot start with special symbol. ID cannot start with digit. So this regular expression is taking care that letter into another bracket, letter or digit star is identifying ID very clearly. So after that, you can see after identifying or after satisfying the string by using the above grammar, we have yyl equal to enter underscore id, return id. Yyl equal to enter id. This particular statement is entering id by using a method named as enter id. Enter underscore id is the method you can see at the last in the semantic actions. Enter underscore id enters the id in the symbol table and returns the entry number. Now next is digit plus. Now you know what is meant by plus. Plus means at least one occurrence and more than one occurrences. So one or more is nothing but plus. So we can say that the entered number is constant or it is a number, then when we can say if there is at least one digit. So digit can be 0 to 9 and it can be combination of that. So 1 is digit, 10 is digit, 100 is digit, 1, 2, 3, 4, 1234 is also a digit. So if such a string is encountered and it is satisfied by a digit plus, it is a regular expression, then we call the method named as enter num. So yyl equal to enter num and return num. So what this enter num is doing, it enters the number in the constants table and returns entry number. So this is the simple example of identification of ID and constant using lexical analyzer generator. So after executing such a program, a C program will be generated. So that C program we call it as a scanner, because that scanner is able to generate particular string and it is going to do some action for that. So I hope you clear this using LEX, how we can accept a string and what we can print by accepting a string. Now here, if we accept a particular string using a regular expression letter into bracket, letter or digit star, then we can print something so that user will come to know that this particular string is accepted and it is nothing but ID. Similarly, if any number is entered, then this particular grammar, this particular expression will be able to identify it is a digit. So this was a simple lecture which was covering only theoretical part of LEX. In the next lectures, we are going to see what is meant by YAC. We are also going to see how a LEX program is executed and what is the output of that. The slide credit goes to Professor D.M. Damdare. Happy learning. Do subscribe the channel to get the notifications of new videos. Thank you very much.